It's working? Yes, I think it is. Check. Yeah. All right. I never can tell if this is working live or not. So, yeah. Hello, everyone. And not much going on tonight. Just figuring out what I want to do next. I have some good ideas. And right now, I'm just conditioning an electret. It's in the oven there, so I got to check that. Make sure. Oh, that's done. Already done. Alrighty. So I'm gonna let that cool down for a few minutes and then put that in the freezer. Just a few more experiments I'm doing in the background here, trying to see what works and what doesn't. Yeah, the power cells are really interesting. I'm really enjoying myself with those. A lot to learn, a lot that I have learned. Different compositions yield different results. I've tried documenting much of it as I could. And I've got a combination of choice materials that seem to work very well. And let's see now. I like this one the most because it's made out of cement and the copper oxide and the PEG electrolyte. And it's working pretty much the same as with just the copper oxide, but the difference is how the texture came out. Much harder, much drier, much more solid compared to the other stuff that's somewhat brittled. So I'm liking it for that. And these ones here are doing nice at keeping their voltage. And, another variant of the cement one works still very well. And more cement ones, more copper oxide ones here. So this one here is kind of cool because it's the one that I conditioned as an electret when I did one of the recordings, and it's still doing its thing more so than the others because this one here was the PEG, nothing else in there. So so now I'm just conducting another experiment. I want to see. I just took one of these random ones here I had with just the PEG, and I'm warming it up as is and cooling it down to see if that's gonna like enhance them some more or not. Just I was bored, I got nothing to do, so I figured may as well try that and see what comes out of it. So a few more minutes, when I can handle that, I'm gonna put that in the freezer. See what that does. I pretty well know what I want to do at this point, so it's not about trying to figure something out that I haven't figured out. It's just I'm curious. So we'll see what happens with that. Oh my goodness, instant messaging is so busy tonight. That's my phone. After I was saying that nobody talks to me. My goodness. Hold on, I'm gonna see what's up there. Wow, my phone just died. So I guess I won't. Should replace this with one of my cells, right? The irony. The irony. There we go, charging. So here we are. And what else am I doing here? Testing one of these high voltage modules, which I believe these may be defective or flunky because I can only get them to run like below 1.5 volts. Never had that problem with all the other modules I got. And I bought another one like this, exactly the same, and I couldn't even trigger it with any kind of battery. It just wouldn't. So I don't know if our friends from China kind of took shortcuts in combining these or what, where it's like a 1 out of 10 kind of deal that works. But I've been really unlucky with these big ones, anyways. Extremely unlucky. So, what am I doing here? Right here. Working on joule circuits here. Oh my goodness, that never happens, folks. I mean, it's at least my phone's charging up, but the messages are like bombardment. Sorry about that, folks. The roommate here is at the hospital, so been sick for a few weeks actually. So just giving me messages, can you get me my jacket? The hospital's just down the road from here, so he was just giving me a list of things he wanted there. So, where was I? Yeah, Joule Thief. This is what I'm trying to build here. I had all these transistors in the kit that someone sent me a while back. Thank you, by the way. So get around to experimenting, specifically low current, low voltage switching. So they have here this NPN. What did I see? The NPN 2N5088, which is a 30 volts, 50 mA NPN transistor. So I figured if I want to switch very low voltages, just generally speaking, that would be a good start for handling near zero current, right? So I don't want it to use the input source too much, so it's crazy, but I got like all these 500 K resistors in series here to the base of my transistor, trying to figure out the highest resistance I can go here for triggering it with just a little battery. It's working really good, I guess. I still want to tweak it, nothing spectacular, but when I run it on this battery here, I get about 250 volts back on the scope. And it's a little transformer, high frequency transformer on here. So it's the high voltage side naturally. So very much like what they got in this thing, without the capacitive diode voltage multiplier stage. So I just basically, I don't know, I have an idea, it's far away. Not sure how to describe it yet because I understand there's nothing special in these kind of things, but just something I want to try for something I want to see down the line if I could use this, potentially running off of capacitors for a while. So speaking of capacitors, I tried building some the other day. Got a bit disappointed. I was expecting like 1 UF or something. I used a Teflon tape. Maybe I didn't do it right. Stack 2 plates in between the Teflon. Something like 400 PF. Whatever. Big plates too. Maybe the conductive foil wasn't the best for plates because it's so thin, right? So that's was interesting. It's a learning experience. It always is. So are the failures, right? A lot of failures, but it's all educational failures. Better than trying to go on Reddit and ask somebody, right? They're all going to laugh at you. So I may as well do it myself and find out, and then tell everyone on the internet, and then they can laugh at me. But hey, at least I tried. Yeah, I'm a little bit on the downside, as I've said earlier. When I don't have a specific thing that I can work on, I get really just kind of like annoyed with myself. I need to be always focused on some sort of a project. And with that said, I don't like giving myself useless projects that like won't amount to anything, like sorting my 90s clip art photo albums and such, which could take hours, but just an example, just ridiculous things. Sorting MIDI files. Yeah. But that's just an example of, if that's what I have to do, I'd rather just sit back and think of what else I can do with this stuff. It's weird, right? When I was younger, maybe 10 years ago, I could take a break from all this stuff and play video games. I had a Sony PlayStation 1, 2, 3. I had them all jailbroken. I had the Xbox. I had them all of them. And my fun was to jailbreak them all and load all the game ROMs in there. And I played a lot of it. But what happened is now I feel that I can't, like, if I'm going to play like SimCity for an afternoon where that's not going to amount to anything at the end, I'd rather use that time to, study something instead. Or maybe it's just getting older and then you realize time isn't like infinite in our sense, you know what I mean, right? Like, as much of it we have here on Earth, when you're younger, you take that for granted and you like do stuff for entertainment value that has no. I'm talking just crazy now. I better go back and focus. Oh, there's comments here. I didn't realize anybody was online here. Faraday Energy Research and Development, Charlie McKay, M4GN3TO. That kind of sounds like a ham call sign, but it probably isn't. So, hello, everyone. Yeah, I just hate live streaming sometimes because, like now, all the phone just going off the hook with instant messages, and you don't have the edit button here. So it's like, wait a minute, folks, I got to see what this is all about. Just because, like I said, my roommate is pretty sick. Anyways, one long story short, life such as it is, right? So, how about your hack RF? I emailed you offering one a while back. Can help you get it running if you don't have a Linux box. Yeah, I've got a few hack RFs right here, actually. Where did I put it? Oh, there it is. I had it running on my Android tablet. I've got a few RTL SDRs, so I'm pretty well equipped with that. So, that's why I didn't, say, make you spend money for nothing to send me that. Because, yeah, I'm fortunate enough. And by the way, for some reason, stupid Canada just passed a rule like basically banning all these devices, which is ridiculous because, you know, ham radio operations, scientific applications, new communication, especially with GNU radio. I mean, it makes no sense. So that's that. Couldn't even sell it on eBay because it said they were illegal. That's crazy. Meanwhile, I'm a ham operator. I've got a call sign. I've got a license. But they don't see the other side of the coin, right? Yeah, I even built a small LNA amplifier module for them, so I was able to boost them to, 200 milliwatts or so. You know, nothing to get you in trouble, but at least to get to the other end of the house. Yeah, exactly. As long as don't interfere with stuff, and you're going to be okay. Especially if you're working indoors, it's so little output. But I find it most intriguing in the microwave bands. And I had this QAM modem, which was very interesting because it worked on HF frequencies. The hams would really get mad at me, but since I was just testing in room, streaming live video on HF, like 40 meters ham. And I'm not talking narrow band live video. I'm talking high speed digital video, like what your cable box is putting out. Yes, it took, a few kilohertz more of bandwidth to do it naturally, but it wasn't that much wider than, a VHF FM. But on the one of the HF frequencies, and then I had the another hack RF to decode that. I took a video of that long ago, long ago, and I had a camera set up like a security system, like in my tech room, so you can see I had like part of my lab, so you can see all my equipment flashing, and that was the remote feed coming in through HF through the QM modem. So that gave me about what was it? Close to 96 kbps, which is phenomenal for HF when all the ham people are trying to do, like 14K or whatever, like half of a 28K modem if you're lucky. So I tried to right around the time, that my ham club went out because most of the members they all passed away because they were much older. I wanted to make a demonstration of that because, kind of a big deal on HF, for spacing requirements naturally. But once you get into the UHF and VHF, you're talking about 256 kbps bidirectional data transfers through the repeaters, analog in the day, which was phenomenal because you're in a time where we're all on dial up. And if you're downtown on Main Street, you might get ADSL, which was maybe a half a meg if you were lucky. So any further than that, so as a ham, you would have, we would have had advantages to be able to like transfer files within each other. But they didn't. If I pushed too much about the new stuff, they didn't like it. So I had to hold back because I liked them a lot and I didn't want to intimidate them because I was learning myself, especially the old stuff, the magnetic amplifiers, the regenerative radios, the tube amplifiers. They were the experts at all that. And even in my day, at 15 years old, when I got my ham radio license, it was all sold state, You go order a Kenwood or an ICOM and just learn how to plug the antenna to the cable without shorting anything out. And that's what they call being a ham. And I was never about talking with other people on the radio. Me, it was always about the technology, right down to like Tesla's time. So I was able to resonate with those folks, but right around the COVID, the few of them passed away, and that was it. No ham club, no nothing. But I learned a lot. Let's see what the comments are saying. Wayne Smith, I don't know. Maybe I did at some. I don't know. I was for a while, I was going to Dayton, Ohio, at the Hamvention with a group of people, and we would all meet there. And Maybe they were part of that group. I don't know. Probably not because I don't know because they would. My call sign's VA3JFL, so if that matters. But I'm from Ontario. I would only go down. I would go down to Dayton, Ohio, for the Hamvention. I did that for a few years at the Hanna Arena. Then a tornado swept through or something, and that had took the whole roof down. And now they're doing it in a horse racetrack, I believe. I've never been there since those days, but I really enjoyed it at the Hanna Arenas because that was a big, big thing, and it was like one giant. You had the scrap yards outside with all the tubes and the equipment. A lot of it didn't work, so you had to know what you were looking for. And unfortunately, I didn't have a lot of hauling, space because we're all, driving, one van for 6, 7 people. Well, not that many, but you know what I mean. I was just a teenager at the time, so I didn't have my own vehicle. So it's not like I had the luxury of just stacking myself up in the end. So I would selectively find, oh, here's a dummy load. Oh, here's an induction coil. Oh, here's an analyzer, 5, 6 things I had on. Because eBay was just starting, but it wasn't hot. But I believe eBay killed that show down the road. Let's build a time machine. Yeah, I can't really talk about that. Uh, Dare to dream, right? So what was I talking about? Ham stuff. Yeah, what inspired me and everything. The ham folks, but I had to be careful, right? I couldn't go out of line because it was all for ham radios. So don't talk about anything else. But they were good at what they knew, and I gathered what I could. Sometimes it's just the user experiences, right? Like how to cut a cable and get it just right. This is what the manual tells you how to do it, but here's the shortcut. You take your thumb like this, and oh, okay, well, that seems more practical to me. Why didn't I do that? So, trick of the trades is what they call it, right? Learned a lot of that. A lot of Cat5 cabling, believe it or not, Ethernet cable. Oh, I hated that. Putting it all in the right order and then have them all cut with the sleeves. And I know it's a joke to people, but when you're a teenager and you got to do all that, I found it the most like, ugh. And then had to test them after. Yeah, they're good. Okay. Hmm. So, oh yeah, let's see. I had this electric thing in the oven here. All right. I'm just gonna see if that worked. Yeah, that worked. It went up 250 um, millivolts. I was gonna say microvolts. Oof. So zero point 0.2 of a volt simply by heating it up and cooling it down. That's really interesting. So that's good to know as far as the power cells go. Something to take into consideration. maybe. So yeah, a lot of my high voltage modules are defective or flunky if you get the bigger ones. The smaller ones I never had problems with. They work great actually. They work on the little pill batteries. Super impressed. But the big ones, I'm looking on eBay right now. It's pissing me off. 270 some US. There's a nice tube, 1,500 variable power supply. Just like new, works, new tubes in there. And naturally, high current as well. So I'm just getting tired of everything burning down for an experiment all the time, right? Or, this stuff here all works good, but you run a spark gap for 5 minutes, everything gets hot, hot, hot. Or they're pulse generators. They're not designed to run for an hour while you're doing an experiment. Some stuff, it's not always about, not using zero current, sometimes just to get the result and then we figure it out later. But to create the experiment, you need a stable source so you know what you're doing, and these things don't always. So that's where some of the old stuff comes in good. Magnetic amplifiers and tubes and stuff like that. Because when you start playing with high frequency, high voltages, and all that stuff, you end up with obviously inductive kickbacks. Sometimes you get events that are unknown that you're not even aware of that would shatter. Bedini actually drove him nuts, ran transistors at random just popping across the room. Well, the old tube stuff, for prototyping at least, so you can get your bearings all together and figure out, is good to have. So anyways, yeah, I saw that on eBay and it's like two something, and I'm like, oh my God. It would be so bad, like I'd call my parents and say, look, can you lend me $200? But my goodness, it's like $130 to ship. That's the problem about being in Canada. Everything, you're paying half or more of the item in shipping. So by the time we're done with shipping, we're 350 US, and now a Canadian is almost a $500 deal. And next thing that's literally half of what I get in a month. So that would work. But ideally, in Dayton, Ohio, back in the day, that stuff was as easy as, buddy, I'll give you $50 for that. Yeah, okay, take it. That was fun. eBay fees can be so cruel. That's the problem, right? For the sellers, you gotta anything under $100 are not making any money. You're wasting your own time to pack it up and to figure out the shipments and to bring it out to the post office. So I see their angle too. They want to cover a bit of their labor, but for us people, it makes it very difficult, money-wise, anyways. Yeah, the send the fly back into HV comment. That's exactly what I'm doing. What's funny? I already built the transformer. You beat me to it. But this is I'm working on exactly sending the pulse. Yeah. Anyways, there's something I want to try, and down the road I want to couple that to my power cells. So I'm sure you all know where this is going. A little bit of Don Smith at the miniature with my power cells driving them and using magnetics. Exactly like you said before, to stick with magnetics. So guess what? We're gonna stick with magnetics. Seems to work. If it ain't broken, don't fix it. Magnetics. Gotta love it. So yeah, like I said in the title, I'm just random chit chat. I know what I want to do there. Something else with the cells. I think I'm going to buy all these ice trays because that seems to be the best geometry, and just buy the peg in bulk. Make a bunch of similar, identical cells all at once so they're identical. The same geometry, the same symmetry. Have like 2 6 stacks on each side of the ice trays. Make sure they're well molded in there, all well contacted and isolated naturally. And yeah, I like to do that and introduce all this magnetic stuff to initiate a feedback sequence. And of course, without getting into the details, you know where that takes us from there. Have it all nice, you know. So that's what I have in mind. But at the end of the month, I'm going to buy some of that stuff to do that. I'm out of carbon felt. So I got to get more carbon felt at the end of the month to build these new cells. Geometry, the thing is, if you want to run these together, the geometry has to be perfect. One plate is off. It's the equivalent of running, you know, a bunch of different batteries in series. You end up with a flunky balance, right? So you want to avoid that with those cells as much as you can. Yep, you learn from your mistakes, I guess. Yeah, well, over unity, you know. Um, yeah, I get what you're saying, but right now I am focused on Tom Bearden's philosophy of asymmetrical regaging. Whatever that asymmetrical regauge happens to be, whether it's from a wind source or solar or a inert battery or my power cells, as long as this system can continuously regauge per pulse and make up for the traditional losses, you're good to go, right? I mean, a natural battery, I'm going to pulse this battery, right? Through a transformer. I get up, I can step it up, get a high potential, let's say 24 volts out of this. And since it's isolated to a transformer, I could rectify that and send it back to the front. Okay, no problem, but I still lost the VI action from the transformer. Minor, but there's still going to be less, even though the potential is higher, that the current is going to be what we put in minus the losses. So traditionally, what's going to happen to this battery is it's eventually, you know, the VI curve is just going to keep going down until it dies. Now, let's picture you have another source. It can be a cell or any external source from the environment. And after each pulse, it can regauge through whatever mechanism you have. Then that changes the game, right? Because when you send that joule back to the bus, it's available to go again, and you've made up for the losses, right? So then you got an amplification factor. As long as the system can regauge. So there are several mechanisms to do that, right? But right now, what I find interesting is the behavior of how these cells can be pulsed. And, you know, because it's mostly an electrostatic effect, you can short these for a day and unshort them. And as soon as they're unshorted, poof, they bounce right back. Charge capacitors in a flash. So that's what I mean by the cell-free. It's not the typical battery where you take a pulse, that energy, while part of it is lost forever, and you're always going to have. So even though we have the same losses in the transformer through VI action, the power cell that I'm using is again fully charged, available for the next cycle. So even though, we wasted 30% in the conversion, we're still sending it to the front plus the next pulse. That's how you can amplify it in simple terms. But I guess it's applicable to just about every system we work with, regardless of the source. Yeah, I know all about the Bellini stuff, and I don't want, I get it, but yeah, I did all of that. It works, but unfortunately, most people, it's out of their league, and the conditions have to be pretty darn good. It's great though, but it's not. I'm going to be honest. It's never going to be in the mainstream. Um, I tried very, very hard to simplify some of the concepts with some success, but what seems to work a bit better is the Don Smith kind of things. But you really got to understand the magnetic amplifiers and how you essentially modulate a high frequency with a low frequency and recreate your waveform. But still complicated, but I believe there's more potential in outputs doing it that way than messing around with a Bedini. Just opinion. I mean, it's probably wrong, but that's how I feel, anyways. So this is why I'm interested a lot in these little power cells because they're relatively easy to build, as simple as traditional DC systems to manipulate, essentially, with the added benefit that they self-regage. You always have that potential ready to come out at you every pulse. So it's not like the battery, has 90% and eventually is going to go down to 40. These cells don't drop that way. So yeah, I have ideas, a lot of ideas. Things that I've tried, things that I haven't tried, and then maybe even hybriding them with Bedini systems, half and half. So much to try, really. There's never, it's like there's no ending to all of this stuff once you really get into it. Yeah, most get discouraged, and Bedini doesn't do a great job himself maybe, I don't know, but a lot of it, is your own, like you say, your own. After playing with it so much, you realize what the little mistakes are, right? But Bedinis are nice, but there's so much more stuff out there. I think, anyways. I find the what is his name? The Dollard gang there so focused on just the Bedini concept. The Bedini's been gone for a few years now, and these people just recycled it. They write books and put out DVDs just trying to recycle the same old over and over and over again. It's like, guys, there's more to this multiple coil system than, they really like Bedini's multiple coiler, and they have a few of them built and they demonstrated. They have, like, sometimes they have their little call-in shows, but it's all the same thing for the last, I don't know, 4 or 5 years that I've been watching them. It's the same stuff. And if you get slightly out of line with that kind of thing, they'll just You know, don't go back into it. So, um, yeah, it's a pretty quiet night. I conditioned another cell. That was successful. And I'm planning out everything I want to get because I want to make a really professional setup that's going to initiate a self-feedback system. But one step at a time, one step at a time. I'm trying to build John's device. You know, the first one he had when he took a bunch of his cells and used that for feedback. I know pretty well what he was doing there. So I'm trying to replicate that essentially with my cells. So yeah, just testing out a few concepts here. I'm not going to use any of these parts. Just it was just to get my brain going here. So yeah, what am I gonna work on tonight? Again, like I say, I hate not having. I've got materials, but I'm missing the workshop, which I keep complaining about. Got this magnesium anode here. I got to cut these all into little pieces, maybe an inch and a half, all the same. So difficult finding just metal around here. You know, just a random mineral you're looking for, whatever. I mean, I had to go to the hardware store, and this is for a water tank. So, of course, you're going to pay more. Well, again, one day we'll have all of the stuff. Gives me a lot of time to think and be creative. If anything, I could be Mr. Steampunk. Let's put a Tesla coil on top of this and running around with duct tape and a few water valves and a lamp, and there we go. Voila, free energy. Don't laugh. I see those contraptions for sale on eBay and I go, oh my goodness. With the lamps and all the steampunk stuff there, you know, with the lamps and the valves and the big analog gauges. That the whole thing takes about half the table in space. So, yeah, I'm gonna have to check this LC meter. I think it's acting flonky because I was testing my capacitors the other day and it sent something like 68. Um, the L value was like completely out to lunch and relative to the capacitance. So, but I tried it with a known capacitor value and it was okay. So, but this is just hobby stuff, you know. You buy on the internet from um, essentially the Chinese people on eBay, and I always wanted to buy like the real rack mount version, an real LCR meter, a real one, not just a toy, but it's better than nothing. At least it gives me a rough idea. But with that said, if they're gonna start acting flonky, it's not good. So I'm gonna have to test it there because I got suspicious with the last readings I got with it. Very suspicious. And then I clicked on frequency, And it was not even the frequency that would have been in resonance with the value it was saying. So I don't know, maybe it just needed a good reset. Foofy, come up, come up. This is my dog, by the way. She's really annoying, always wants attention. So when I start talking or whatever, she's the one you all folks usually hear in the background. And I keep saying, it's a good thing she's cute, you know, and she's really a good dog, really just likes to be friendly, so always needs attention, likes to be pet, likes to be the focus. When I'm talking and it's not about her, it has to be about her. So with that said, Fufi is her name, by the way. Okay, down, 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 down. You're heavy. Oof. I'm gonna start calling you Fufat. Fufat, not Fufi. Fufat. You know, who feeds you that much? She's on a diet, by the way. I'm actually measuring at half a cup, like the vet said, because enough of that. Anyways, I'm sorry, folks. Here I was, doggy just came and said hello here. That's the wonders of being live. Can't edit it out. So yeah, I learned a lot playing with. My personally is I like all this electrostatic stuff, the one wire, the heavy side vector, the pointing vector. Actually, it's all good stuff, and it's all in that it's all in relevance to the electrostatic potential. So very to me, anyways, it's what interests for now. So I've been a little bit more focused on that stuff. And a bit of old style switching, magnetic amplifiers. Really need to get into that. Some of the older methods were, I guess, the best. Uh, Fufi, you're being really noisy. You're being really noisy. No, 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 no. Go lay down. I'm busy. I'm busy. Fufi. Telling you. Always wants attention. One thing though, when I do my experiments, she goes in another room. It's like they have senses, right? They could hear the electrostatic zaps and whatnot, and she doesn't like that at all. So when I start like touching the wire and stuff there, usually she sees me and rushes in the room. Not doing it on purpose to scare the poor thing, but they're just more sensitive to electric fields and that kind of thing. So when I start experimenting, she never liked it. Maybe she'd be better than my scalar sensor. Hey, Joel, the name is Gerald. Oh, she has kind eyes. Yeah, she sure does. So yeah, it's nice to see. I'm surprised, just going random live, how many people just show up. But I guess it's a better format than not having anything at all, and because then it keeps everybody up to date of, I guess, what's the background, of the what I'm thinking about and what I'm want to do. So the deal here is I'm still looking for a lab, a workshop. It's very difficult in a small town to find someone, who has anything, like a garage or something. But I'm working on that because a lot of like machine stuff I'd have to work on. I have to make a control panel actually for one of my microwave power supply projects for a high voltage electrostatic project. I was going to order like a emergency shut off switch. It's a control panel for that. And I'm looking for a special feature, I don't know what it's called. Maybe someone can help me. Where the emergency shut off actually has a kind of built-in shunt where it'll take the inductive kickback and send it to ground. Like a real like for like maybe it's something that's really basic, but I need like something really heavy duty, that if I'm working with tubes or something like that at high currents, and I won't kill, everybody down the wire with an inductive kickback. It'll just go to ground. So I'm plotting that in my mind, but that I need a garage. I need some wood, some steel. I know how to weld. I know how to cut. So I want to do all that. So what happened is my parents have all the nice stuff. My dad, big garage, big workshop. But, that's always been his man cave, right? So it's never been my business or anyone else's business. And I'm sure most men understand this. It's your stuff, it's your life, it's your organization. You don't want anybody screwing around with your stuff, right? So it's your life, it's your trophy. So I get that. But with that said, the garage has always been out of bounds for me. So I never was able to really make full utilization of that and go there, even I might make myself a spawn. But, like in all things, everybody gets older, and my poor father, could hardly walk in the last year and broke his hip. That took almost a year, and it didn't fully come back. So, one long story short, going on 80 soon, um, and not in the best health. So, it's been a few years now. He hasn't been able to do anything in the garage, and he's got all the stuff. So I've been trying to be really, really, really nice, folks, like super extra nice in the last, few months, trying to hint and at the idea that, you know, maybe it wouldn't be such a bad idea if I could use the garage and make it into my lab. It's got all the stuff, all the scrap metal, all the tools and the machining and everything I would ever need to do what I got to do, and I wouldn't be hurting anyone. And he has to heat it anyways, and no one's using it. So at this point, I may as well be the one to use it. But again, it's his man cave, so you got to take it easy, small steps, not just, hey, Dad, I want to take over the garage, get out. Just like, hey, feel like doing a cleanup in there. I can help you out with that, with all the big boxes. Be nice and, take it step by step, maybe. But I have it right in the back of my mind of trying to get that without causing any trouble and be on everyone's good accord. That would be very helpful at this point. Yep, that's the ground reflection I talked about. That you can tune Tesla coil with the ground, have an identical Tesla coil underground for yeah. That's very well. That's actually how I was saying that people should do it because they didn't understand what I meant by ground tuning. I want to create a reflection, and for the maximum efficiency, it has to be resonant. You're literally creating a dipole in simple terms. You're gonna get ready to do a lot of digging, my friend. But yeah, that's it. Ground tuning very important if you're serious about like what Tesla wanted to do and that kind of thing. Oh, my floopy did her puppies on her pad. At least she's trained, which is good for me because I don't have to take her out on all of the snowy and rainy days. There we go. So for tonight, I gotta start cleaning stuff up here. It's one experiment after another. Okay, dokie. So I guess I've been chit chatting for all this time about just nothing pretty well. So how long has I been on now? Does it say on it? An hour almost. Oh my goodness. I just go on and on, don't I? So, yeah, as far as digging the ground and putting Tesla coils underneath, I know someone who did that in Timmins, Ontario, in the mine. They used the mine for an experiment, and they put the Tesla coil down into the mine, and they sent wireless power halfway across the country. Tim Richardson, local guy who did it. He did. He went to study in. It was, I believe, in Germany. He learned German, and he was a Tesla fan, and originally read some of all the stuff they had on Tesla in that language, I believe. So, anyways, Northern Ontario Wires hired him. He's their main tech. He built all the power plants, well, engineered them all in the north here. And the government of Ontario wanted to do this experiment back in the 80s. So they took one of the mines in Timmins and stuck a big Tesla coil in the mine. So the big Tesla coil was in the mine shaft, and there was a reservoir, like a riverbed. They grounded to that additionally. And what he did is he put a flat coil. They wanted to keep it low profile, okay? So on the top of the ground area, so there wouldn't be any sticking out, they had a big pancake flat coil up there. So by essentially running the Tesla coil resonant, but backwards, they were able to send the electricity all the way out to Alberta. And they had all these remote mines, okay? So the idea was to figure out a way to send the power to these mines by bypassing the Northern Ontario, Ontario Hydro. So Tim Richardson wanted to conduct a second experiment, and they were going to, they were joint this time with some US people, and they wanted to see if they could send the power, like even into the US. So they asked for I think it was 250 megawatts at the time of power from the Toronto headquarters of Ontario Hydro. and they said it was for an experiment, and they okayed it. But as soon as Ontario Hydro found out that it was an experiment with Tesla Technologies and Timmins for to use as a trigger, and like Tesla, every node takes it from the environment, and you're just a trigger. Literally, folks, this is all documented if you do the research and find out. Ontario Hydro, the head office in Toronto, this is in the late 80s, flipped out, and they threatened not only to not provide the 250 megawatts that they needed for the experiment, but to altogether shut down the electricity service going to Timmins, Ontario. They were that threatened of the whole idea of they were going to have this thing in Timmins, and they were going to be able to buy, if this worked, they were going to be able to bypass the electric company to provide their remote mines. So essentially, the project went to nothingness, but because Tim Richardson is local and there's some contractors and everything, they've continued experimenting on and off, but more in a need-to-know basis. And then Tim Richardson is actually still alive today. He's on LinkedIn. You can find him, Tim Richardson, on LinkedIn. He'll talk to you and everything. Really nice guy, but as soon as you mention the word Tesla, he'll be like, who told you about my interest in Tesla? Well, then I tell him what I do, and then poof, just disappears. But he's alive. He's living in Toronto, I believe. Still does that stuff and the power stuff and advanced, nuclear kind of engineer, very educated man, but totally freaked out when I confronted him about the project. And, so and so worked with you, and there's a cousin, and and this is what they witnessed, and this is my 2 cents. Do I have it right? Oh boy, he just block, and we're done. I still see him. He comes in Cochrane because there's a where I live right now, because he participates in a few boards of directors, and they have meetings here. So sometimes, at the Chinese restaurant or whatever, there he is. But I've yet to confront him in person and say, hey, I'm Joel, the guy who was on LinkedIn was asking about Project Timmins with your Tesla stuff you did in your experiments back in the late 80s. Because that attracted military and everything, and that was, if you look into the details, that caused Northern Lights only above Timmins. It scrambled everyone's radio. It attracted the military. Even Tom Bearden knew about this, believe it or not. You could see the doc. Tom Bearden in one of his books it says right in Timmins, Ontario, in one of his events of the scalar weaponry and how he has the proof. Well, without realizing it, if he would have been alive, I could have give him the other half of the story. Hey, as a local, you might find this very interesting. So that was pretty cool, that I actually knew something that Tom Bearden referred to in some of his works and the scalar weaponry and all of that. I know the guy. I actually know the guy. He's still alive. So I won't talk about it. Big secret. Nah, whatever. I'll figure it out one day. You know what it is? You got to follow all those no trespassing signs in the bush, and you find all the secret bases. No, I can't say that. I don't want to get myself in trouble, folks. I do not trespass. Never did, never will. We're just joking. Yeah, he definitely got scared because I started explaining to him his own experiments and how they worked. And, I'm the kind of guy, that gets a thrill off of the verification, like when John Hutchinson goes and says, oh my goodness, you have it. It's right on. That I get my little artificial high out of that moment. So I'm always trying to seek all these people that know all these things, and then I tell them, it works like this, right? But I guess it's not the proper approach for everyone, because then it hits. I could they don't know you from a hole in the ground, and then could be they could see that as a trap, trolling. So I guess, well, it's just my personality. Sometimes I can't help it, and and just bubble in front of the crowd, and hey, I know you. I am coming to Ontario this summer. Oh my goodness, you're not gonna. Yeah, Ontario is great if in the south. Once you get to like north of Barrie, it's I don't know what to say. Make sure you have a lot of Diet Coke soda, maybe zero, to keep you awake. Bedini was one of your heroes. That's awesome. Yeah, he inspired me a lot too. I had a hard time understanding his concepts though at first, especially when he was talking about negative energy. And I'm like, what does he mean? Negative energy or negative? And he would switch back and forth between polarity, right? Because when you're pulsing the diode, it's reversed, and then you're with the diode, it becomes positive, but it's the same spike. You're just flipping the polarity. But he talk about that and then talk about negative energy as just a terminology for, vacuum energy, quantum energy, whatever you want to call it. That was his nickname for it, negative energy. But sometimes he'd have negative three times in the sentence and it all mean three different things in the context, right? So you're the beginner and you think he's talking about, negative polarity all three times when you know, that's what I had a hard time with. And Tom Bearden can be just as bad. But good stuff, really good stuff. The cold, yeah. It's getting better there. Today it got to like, oh my goodness, I think I had flies going around me for the first time. So that means maybe 15 degrees. So 69-ish, 68 Fahrenheit maybe. Maybe I'm pushing it there. But just trying to fluke it here off my mind. I think 68 is too generous. That would be close to 20. So 15 would be 64, maybe 64 today in the sun. Yeah, the scalar wave, of course, but it's everybody has their own terminology, right? And for someone who was new, and I know because a lot of people ask me to clarify for them, and I like to think I did a pretty good job in my. I've got a bunch of videos. What is over unity, open loop versus closed loop, asymmetrical regauging. The meaning of true potential. They're all on there. I made all these videos and tried to. No, Tom Burden says this, and here's a diagram. Here's a Bedini device, and here's the scope, and here's how the waveform looks like, and here's how I could only do the same video so many times before it gets like, boring or annoying to everyone, I guess. So I try to refer people to those older videos if they. Hey, how does a Bedini work? Actually, it's really weird. I get these emails almost every day. Like, again today. And they don't spell very well. It's always like one or two line. Hello, Joel. Please explain to me how I can create the over unity. Thank you. I don't mind emails, but if they really have no context and explain to me how to make the over unity. Um, Go outside and install a windmill and charge a battery. You're welcome. I'll collect my $5 now. I don't know what some people expect of me. It's like But that's with everything, right? I mean, you are broadcasting yourself to the world, so for the best and for the worst and everything in between. Yeah, many names for the same thing. Cold energy, there's another one, I think. But that's more in reference. I've noticed that sometimes there's like this cooling effect. But I wouldn't call it like cold energy, you know. I know Tom Bearden said Floyd touched him and his hands got cold and they got all iced and frostbite. I think that was just for the theoretical value. Honestly, cold energy, I believe, is just when you achieve a state of negative resistance in your oscillation cycles. So the equipment runs more efficient. So instead of, like a transistor, for example, could start cooling itself off instead of heating, and that's area, right? So that's what I think, anyways, because yeah, I've noticed the cool down myself, but that's naturally with everything. If you run it at high efficiency, it will cool down. That's part of it, right? Less resistance, less heat. And then you start ending up borderline with the semiconductors there with the thermal cooling and heating. A little bit more complicated, but it's essentially more of that. It's all electrically triggered. I must have missed some of the conversation. Orlando, Florida. I'm not too sure what that's in relevance to, but maybe they're just all chit chatting with each other. So, yeah, well, I guess I'd like to see it for myself, the whole frost thing. I've never experienced that. Not saying it can't happen. I mean, I've had ball lightning in my place. Try to convince somebody of that, right? So, yeah, just saying I've never had it happen to me with the whole freezing thing. But I've had ball lightning a lot. As soon as I start getting over, let's say 400,000 volts, interesting thing, even at the pure electrostatic, it starts doing weird things. And sometimes time delayed, and not like right away, but an hour after the experiment. Poof, what was that? Then another one, and then another one. And finally, after 6 hours, the dogs finally calmed down because there's no more of them. One time it nearly set one of my bags. I had a bag of, like from the hardware store. Just it got near that, and poof, it actually started to smoke. I was there, and I took him, and I'm smelling this paper bag here, trying to figure out, I'm not feeling any heat anywhere. I saw the smoke. I'm smelling it. It's right here, but yeah. So again, high voltage stuff. I think you need more of a not kitchen stuff. You got to have a workshop, proper shielding, proper grounding, proper shut-offs, proper energy shunts, emergency, you know. But it could all work. I mean, you just got to understand what you got to get yourself ready for, I guess. Yeah, I am in Canada. That's what I don't understand, what Orlando, Florida comes from. I'm in Ontario, living in Cochrane, Ontario right now. About an hour north of Timmins. I was in Timmins there for the last few years. I've been here for maybe 6 months or so. Sorry, I need glasses. Misread. Oh, okay. Orlando. I was trying to figure out, Orlando, Florida. I thought maybe I missed part of the conversation, like you guys were talking in the chat and something came up from Orlando, Florida. And it's like, what? Who's got a generator in Orlando, Florida? Yeah. And I've got all these things. Oh, I still have to replicate the Gerald Morin's hyperdrive. I'm about half done. I just got to figure out the controller for it. Isn't that a commonality, right? Got to figure out the controller. I have a good idea what I want to do. Three phase. It's all three phase. I've already got the motor and the generator. I literally just got to build the switching for it. That's all I got to do. So I'm thinking an ECS controller with a servo. Test it out one day. And then if that works, make a reactive, resonant power supply, three phase. Oh God. I've never played with multiple phases too much, so that's going to be a new learning experience, that's for sure. But we'll get there, and maybe with nice resonance effect and the perfect reactive system, that'll keep the motor going. See what we can get out of it. It's just a small scale. I'd like to get 25 watts if I'm dreaming in color. Mm. So there it is, actually. I think this thing looks so cool. I just got to figure out the switching for it one day. Hard drive motor that spins my three phase. It's all three phase generator. This goes really, really quick naturally because it's a hard drive motor. So just a prototype, that forever in the fantasy land. But again, it's all a learning experience, folks. It's not like I'm expecting over Unity with it just like that, but I'd like to interface it with a reactive power supply in three phase and see. Because a lot of people say, multiple phase is also a way to go. So my way to start experiment, my introduction to it to myself. Higher phase is more efficient. Yeah, of course, because less breaks in the cycle, I guess. I might be wrong. I think one capacitor phases 60 degrees. So you need three capacitors to get a 180-degree phase. I'd have to look it up. But yeah, something to do on a rainy day, I guess. Study three-phase systems. That's going to be a lot of fun. Ah, that's what he's all about. Yeah, makes sense. Because that's a lot of that is electrician stuff too, right? Because they're more used to playing with three phase because it's all commercial motors and industrial, right? So anyone who will have went to even traditional engineering will understand a good part of three phase systems or more. 360, nice. Yep, they're just partially out of phase. A little bit of that. I do it all with capacitors when I experimented with trying to vary the phase. It's quick and dirty, anyways, without needing any digital circuitry or whatever, right? I mean, well, I don't think there really is a limit on in theory, how many phases you want to go, right? I mean, but yeah, and relevant to a generator, it would make sense because you want to fill out that waveform with as many spikes as you can in peak amplitudes, less of a ripple in the waveform means more energy dissipation. What am I trying to say? Dissipation. Whatever. Is it getting late? No, it's only 9 o'clock. And I usually can't talk. It means I'm getting tired. Yeah, that would be a cool project, right? Make like a super phase motor. But then wouldn't that look kind of like a DC signal if there'd be so many phases and they're just, you know, Mhm. Yeah. I think that's where, in part, the Bedini, when all of his multiple coils, uh, that would make sense, especially if a Dollard, Eric Dollard is so into that. It would probably line up in their interests. So, yeah, I guess I'm going to wrap it up there and say good night to everyone. This was just a little update here on things, nothing major. Just I was trying to condition a cell earlier, and note to self, you can recondition them. That's good to know. So, yeah, with that said, folks, I'm going to say goodbye for now and keep you folks all up to date as I get updates and ideas and projects and everything. And yeah, thanks for spending part of your time with me there. And until next time, folks. And we'll see you around. And don't mind the bad quality here because it's live and it's just my laptop. So enjoy the rest of your time, folks.